let's see if we can straighten out number 12 from 18.2, which is, wait, they give me a vector field f, which is yi minus xj. They tell me that C is the right-hand side of the unit circle starting at 0, 1.
So a quarter of the circle?
Well, what the heck am I supposed to do?
C is the right-hand side.
So I'm assuming they mean half the circle, right?
Yeah.
Right-hand side.
Counterclockwise change. Quadrant 1,
Well, they're kind of
quadrant
flipped,
4.
like that'd be a quarter, right?
It said quarter, didn't it? Or right-hand side of the unit. So
Okay.
yeah, it's half.
Here's the unit circle. Where's 0, 1 on it?
Pi over
Top,
2.
pi over 2.
Pi over 2, so top. So where's the right-hand side?
Yeah, the right
So
side.
we're going clockwise,
The only thing I thought that was weird, I think the solution says.
Yeah, they have to
traveling 0 to
parameterize
pi.
it backwards.
Yeah.
Alright, so they want me to go that way,
Yes.
which
Yeah.
is backwards of the way I usually do circles, right? Okay.
A slope field.
It's okay, we'll straighten it out, but first, what the heck am I supposed to do with this F and C?
Do
Converted.
parameterize.
You guys are skipping this stuff.
Convert it into.
They want me to find the integral over the curve, right?
Oh.
Of F dotted with theta. Okay, so I'm gonna start there. I'm gonna say, okay, there's a line integral, right?
Yep.
So first things first, on a line integral, what do you need?
Parameterize.
Yeah, you need this word that none of us can say.
Yeah, it sucks.
Parameterize?
Very nice, right? Yeah, we need a parameterization.
Parameterize.
We need to find a way to describe the curve, right? Right. I don't
Okay.
care if you could say that word. It's not gonna be on the final. Okay, I promise.
Yes.
Put it on
So,
the final.
what would your
Spell it.
usual,
That looks like sine and cosine.
yeah, so usually you do r of theta, right? And you'd say, okay, r of theta is,
Is cosine
Cosine.
theta sine theta?
yeah, so you do cosine theta comma sine theta, right? Which goes, starts here and goes that way, right? Crap.
So.
Okay, but that's okay. We can adjust. We just need to know when it starts and stops for the times, right?
Well, that would just be pi over 2 to negative pi over 2, right?
Perfect, right? Up here is theta is pi over 2, right? Down here's theta equals minus pi over 2.
That's gonna get funky in the integral though. Right? We wanna do,
We can't do 3 pi over 2
Yeah,
because that'd be counterclockwise.
Yeah, so I can't do pi over 2 to 3 pi over 2 because that'll be the left-hand side. But I can do, let me see. I just want to say this as, all right, this thing is an integral of f of what? Perfect. R f of cosine theta comma sine theta, right?
Yeah.
Dotted with,
Dotted with negative sine theta, cosine theta.
okay, and then I'm doing d
D theta.
theta. And now I've sort of hardcore committed to this parameterization, right? So here I've got f. This stuff in here is r of theta, right? This stuff in here is r prime of theta. Symbols are hard today. Okay. But what are the bounds?
From
From
pi over 2 to
negative
pi over 2.
negative pi over 2 to pi over 2.
No.
Pi over 2 to negative
So
pi.
they
Zero
want me to
pi.
go this way, right? They want me to start at the top and go to the bottom. So I just go to the time that corresponds to the top. That's pi over 2. That's where I'm starting. And then I want to go to negative pi over 2. That seems totally backwards, right?
it is though, sort of, because our theta is.
Good. It is
normally
backwards,
that way.
right?
We're just setting the direction that we want.
Yeah, I just had, they gave me a backwards curve, right? So I'm going to give them a backwards integral.
Yeah.
And of course you can flip this, right? You could just flip these two guys and what?
Interchange the sign.
Yeah, throw a negative sign on the outside. You guys remember that from one-dimensional calculus, right? It's the exact same trick, right? This isn't even different because this is a scalar function, right? I'm integrating it. I'm doing Calc 1 now. Right? Setting it up was a Calc 3 problem, but executing is Calc 1.
When I got to here, that's exactly how I did it, but then when I looked in the solutions, it said 0 to pi. I know it's the same, but
So they probably did some kind of funky subtract pi over 2 and use an identity.
okay.
There's lots of trig identities that you could go fiddle with. I wouldn't advise that you have any of them in your head.
Okay.
But there's a couple nice ones that sine and cosine of theta plus pi over 2, right? Or minus sine and cosine. So there is a trig identity there. I'm sure that's what the solutions may be. For me, because I don't know any trig identities, I'm not going to do it. What do I get when I evaluate f? So I've got the integral from pi over 2 to minus pi over 2.
Of sine
Minus sine
theta,
plus.
comma, negative cosine theta.
Of what now?
Sine theta, comma, negative cosine theta.
Sine theta comma minus cosine theta.
Dotted with negative sine theta, cosine theta. D theta.
Perfect. Is he nuts or are you all with him?
And then it can become sine squared plus cosine squared with a negative out front.
Okay, so let me straighten out. Was anybody confused by this stuff? Or are you all okay?
It's because the
Yeah, it's because the x and the y are switched in f, right? And maybe we'd look at f and think, okay, f is y comma minus x. So when I feed it an xy, I need to switch them, and then I need to pop a negative sign on the second bit. Okay, so then we can multiply out, right? We get our dot product. So we get integral from pi over 2 to minus pi over 2 of
Negative sine theta, negative sine squared theta.
negative sine squared theta minus cosine squared theta, d theta,
Take out a negative.
pull a negative. Okay, so I get the integral from minus pi over 2 to pi over 2 of 1 d theta. That's all pi into that line of
Same
ds.
answer whether you flip it or not, right?
can you still have to have a negative on the outside, or flipping it?
Well, he
makes
flipped the
negative?
integral.
Flipping it makes
and then
the
he took
negative
out a
Okay.
negative.
inside. So either or, right? You can either pull a negative out and leave them from pi over 2 to minus pi over 2, or you can pull a negative out, flip them, and then it cancels.
Which, that's gonna end up becoming one, pi.
Okay, so this is, in the end, theta evaluated from minus pi over 2 to pi over 2.
Yeah.
You get pi out of this. Okay, cool. Thoughts, questions, concerns?
So doesn't the path exceed the field completely on this one?
Yeah.
It's positive, so you're actually helping yourself.
Isn't that kind of because the vector fields would be that circular motion that we saw the other day?
Well, the vector fields.
Yeah, so this
negative
vector
x.
field is circular motion agreeing with the path.
Yeah, okay.
And so what's happening is, as you go along this path, there's unit speed flow going with you. So of course, the amount of help it gives you is exactly the length of the curve.
If we reverse the direction, would it still be pi?
So if I reverse the direction, it'll be minus
Zero.
pi.
Minus
Yeah,
pi?
'cause
Yeah,
you're-
because what's going on here, right, is there's this flow that's in here. And this flow is like this.
Okay. No, when they're opposite directions, they're negative.
Yeah, it's exactly the tangent to the circle. And
Okay.
if I go back, right, of course it's gonna be hard. Right, I'm gonna have to swim upstream the whole freaking way, exactly into the current. Guys see that? Notice that if I went the other way, right? Like not the other direction on the same path, but the other path, see that? Like, if you're standing here and you wanna get up here, that was gonna be a cupcake, but I suck at drawing cupcakes. So if I wanna get from here to there, right? If I go this way, it's all uphill, right? Or all
Yeah.
into the current. If I go this way,
It'll be helpful.
yeah, it's all with the current, right? So this is a vector field, or this is a vector field, right? That's not path independent. It matters which way you go to get from point A to point B in here. Cool?